Well, welcome to Math Blossoms. We're growing and mathematics is natural. I am the teacher, Miss G, and for today's topic, we're going to learn how to calculate slope from a graph and from tables. It's pretty easy when you know how to do it, so I'm excited to show you how. Let's get started with slope from graphs. Okay, our question is, how do we find the slope from a graph without using the slope formula? You can always use the slope formula to find the slope. The video that talks about finding the slope from ordered pairs and equations, that one is showing you how to use the slope formula. That's the one you should probably watch after this one. But for graphs and tables, it's pretty easy. You don't really need to use the formula. So I'm going to show you the method without using the formula. First things first, slope is the ratio of the vertical change to the horizontal change between two distinct points on the line. First, find the two exact points on the line. And if you don't know what I mean by exact points, a line consists of a whole bunch of points like squeezed together, right? So if you're looking at this blue line here on the graph, I could choose any of those points and say, like, this is a point. Like, I could pick any place on this line and say, hey, there's a point, there's a point, there's a point. Just any spot is a point. But exact points are points that don't just fall on your line. They also fall on a corner of one of the grid squares. So if you notice, this point that they chose here and this point that they chose here to calculate their slope from, it doesn't just fall on the line, it also is on the corner of a square. So that's what we mean by exact points. We need to make sure they're exact so that we have whole numbers to work with. Otherwise, you're going to be estimating or approximating the value of that point with fractional points. So that's why we need to make sure it's at the corner of one of those squares at an intersection, of the graph so that we can have an exact point. Next, count the distance between the two exact points vertically. So that would be your rise, up or down, and write that number in the numerator of your slope ratio. Then count the distance horizontally from left to right and write that number in the denominator of your slope ratio. So as you can see, they've taken the 2 points they have here and they followed the lines of the graph up and over towards each other. So from each exact point, you're going to draw like a little triangle. And then you're just going to count, what is the rise? How far up did it go? It went 1, 2, 3, 4, 5 squares. You just count. And that's how they got the 5 squares. And then the run, which is the distance horizontally, that's 1, 2, 3, 4, 5, 6, 7, and 8. Remember, you have to go all the way to the points you chose, right? So that would be 8 as your run. So the change in y, the vertical distance, is 5, and the change in x is 8. Now, it's very important that after you use this method to find your slope of a graph, you check to see if the sign of your graph is positive or negative. Because if it's not a positive sloped line and you don't put the positive there, it will be wrong. So you want to make sure this is a positively sloped line because it is going from left to right up. If it was a negative sloped line, it would go from left to right downward. Okay, so we have to make sure that it is positive, because if not, we would have to take that 5/8 and we would have to add like a little negative symbol here, right? If it was a negative one, which it's not. Okay, so that being said, if you do get a ratio for your slope, the idea is to simplify it. So if you divide it and get a whole number, then that would be simplifying it, or just reducing the fraction to a smaller version. That's also simplifying it. This 5/8 cannot be simplified anymore, so we're just going to leave it the way it is. All right, here's another example, slope rise over run. As you can see, the blue line, they have drawn some triangles from two exact points here that fall on a corner of one of the grid squares. Everyone actually, if it's on a corner of a square, it's usually on the corner of like 4 different squares. But you also have, the vertical distance being counted as 2 and the horizontal distance being counted as 3. So you can say the slope of the line has 2 over 3, 2/3. Now, this is also positively sloped. It's moving from left to right upwards. Here's an example of a negatively sloped line from left to right. It's moving downwards. And as you can see, the rise is 1 and the run is 5 squares. So -1/5 would be the slope for that one. Okay, let's try some so that we can get used to how we do this. Little practice sometimes is necessary. Okay, there it goes. Okay, so we're going to follow this line from our first point up, and we're also going to follow it over. This will be the run, the horizontal distance, and then this would be your rise. And then where they meet is in this little corner right here. Okay, so again, follow it from the 2 points that you have, the 2 exact points, and just follow the lines of the graph until it meets at a right angle there. Okay, now that you've got that done, we just need to count. Okay, this rise distance is what goes on the top of your ratio. This is 1, 2, 3, 4, 5 squares, 5 squares high. And then the run is 1, 2, 3, 4 squares. So our ratio is 5, which is the vertical distance, over 4, which is the horizontal distance. Rise is the vertical distance up and down, and the run is the horizontal distance, right, left, right. Now we got to look at our line because this is not a positive slope. If you look at this line is moving from left to right in a downwards motion. So because of that, we need to put a little negative on our slope. So our slope for this one is -5/4. That cannot be simplified. And we never really turn our slopes into mixed numbers. I realize that this can be turned into 1 1/4 as a mixed number. We don't want to turn our slopes into mixed numbers because it's easier to use the improper fraction when we go to graph the lines. So it's best to leave them in improper fraction form if you get an improper fraction. Okay, this next one is a horizontal line. So we just have to remember that if it is a horizontal line, horizontal, the word comes from the word horizon. And so you can think of it like as sitting on the beach, and that's like the line of the water, like the ocean. And this is the sunshine coming up. Like let's say it's the sun rising over the ocean, or sun setting over the ocean. This is horizon, okay? So if it's a horizontal slope, we know that it's 0. There's no steepness to it at all. It's just laying flat, right? So you just have to remember that. Now, one of the things we're going to show you in a video later on is a mnemonic device to help you with that. And this is part of it, HOY. And it stands for horizontal, 0 slope, and then the y is how we write an equation for a horizontal line, which we're going to discuss in a different video. Okay, now this one, we have our 2 points, and we just need to draw another triangle. I'm going to follow the lines of the graph from each point vertically and horizontally until they meet. And then we're going to count. We've got 1, 2, 3, 4 squares vertically. That's our rise, or rising up 4. And then we have a 2 squares run. So our ratio for this one here would be 4/2. Now 4/2 can be simplified. 4/2, 4 divided by 2, that's actually a 2. So 2 is our slope for this line. And this line is a positive line because it's moving upward from left to right. So we don't need to add a negative symbol on there. And we're done with that one. The last one is a vertical line. Vertical lines have a slope of undefined. You just need to remember that so that you can write it down. When they're asking you what's the slope of the line, you will know that this one's an undefined slope. Another word that we're going to learn in a future video is VUX, V-U-X. V stands for vertical, U stands for undefined, and then the X stands for the equation that represents a vertical line, which we'll talk about later on. Okay, how do we find the slope from a table without the slope formula? First, the slope is the ratio of the vertical change to the horizontal change between the two distinct points of the line. First, find the vertical change by finding the difference or subtracting between the second and the first y values, starting at the top and moving down, or starting from the left side and moving to the right. So it depends on if your table is like the one on the right here, where it's, kind of a starting at the top and moving down, or if it's a table that reads left to right, like this one on the left here. Write the number in the numerator of the slope ratio, and then second, find the horizontal change by calculating the difference or subtracting between the second and first x values, and starting at the top and moving down, or starting on the left side and moving right. Once you've done that, you would write the number in the denominator of the slope ratio. You would simplify or reduce the ratio if necessary. So there's an example of what they're talking about here. They're saying, hey, remember, slope, another name for slope is not just unit rate. Another name for slope is also called rate of change, right? So if it's rate of change, that means I'm finding how did 2 change to 4? What did I add to 2 to get to 4? Well, I added a 2. And if you notice, how did I get from 4? How did I change that to 6? Well, I added 2. So this is adding 2 each time. Right? That's my change in x. My change in y, if you notice from 0 to 3 here, you're adding 3, you're adding 3, you're adding 3. So they have placed the change in y over the change in your x. This little delta symbol here, this little triangle here, that just means change in y over the change in x. And the change would be 3/2. That's your slope, 3/2 for this table here on the left. Okay, on the right, you've got a change going up 2 each time. If you notice here, it's going up 2 each time. It's not just the very first 2 points, it's each time, okay? And so you can get these values by subtracting the second. Like if I did 5 minus 3, if I subtracted the second y minus the first y, I would get the 2, right? And you could do that on the x's as well. This is going up by 1 each time, plus 1, whoops. This is going up by 1 each time, plus 1. And sometimes you'll find that sometimes to get from the first to the second y or x, you'll have to subtract and not add. And that would make like a negative sometimes. So be careful of that. So this one would be 2, which is our change in the y values, the vertical distance, over a 1. And 2 over 1 is just a 2, right? So our slope is 2. Let's try some of these. Okay, so we have, what are the slopes of the following tables? So let's take some of these and see what's happening. Now, what's happening between the 5 and the 2? Well, to get from 5 to 2, we don't add, we would have to subtract a 3, right? And to get from -3 to -2, that's not a subtraction either. That is adding a 1. If I add 1 to -3, I'm going to get a -2. And you can plug that in your calculator. If you take the second x here, the second x, and subtract the first x, which is this one here, right? -3. If I subtract -3 from -2, I will get a 1, okay? So you can put it in your calculator to figure it out, or you could just think about, how would -3 become a -2? Well, it's going more in the positive direction, so we're just adding 1 to it, right? Now, this is happening each time, right? We're subtracting 3 from 2, and we get -1. If we subtract 3 from -1, we're going to get -4, and so forth. So if we write our change in y, which is -3, over our change in x, which is just a 1, that slope simplifies down to just a -3. Let's change colors. Okay, the next one, what is our change in y? Our change in y is going up by 4. I would have to add 4 to -17. Again, if I wanted to just plug that in my calculator, I would take the second y, which is -13, and I would subtract the first y, which is a -17. I'm putting it into the parentheses so you don't get the negative mixed up with the minus. And when you do that, you'll get a 4. And this is going up by 4 each time. So our vertical change is a 4. Okay. And on the horizontal change, the x change is just going up by 1 each time. So it would be 4 over 1, which simplifies, 1, which simplifies down to just a 4. Ooh, my mouse is starting to stop working. Hang on. Let me fix that. There we go. Okay. The next one, as you can see, it's going up by 2 each time, plus 2, so forth, right? And then there is no change between the x values, so we're going to call that a 0, right? So what do we do when we have 0 change? We're going to put that in our denominator, 2 over 0. And since you could not divide by 0, that is an undefined. In fact, if you put this 2 divided by 0 in your calculator, in your Desmos calculator, Desmos will actually put undefined as your answer. It will tell you it's undefined. In some calculators, it'll just show you error message. When you try to divide by 0, like in the handheld calculators, it generally just says error. But on Desmos, it actually tells you it's undefined. It has that word undefined, which I thought was useful. Okay, now this means that this is a vertical line because vertical lines have those undefined slopes, right? And if you notice, all of the x values are the same in a vertical line. And so you can kind of just look and see that sometimes and not even bother trying to find the distance or the change in your y over the change in your x, because if all the x values are the same, you know it's a vertical line and that it will be undefined slope, right? Now the last one over here, let me change colors again so we don't get them mixed up. Okay, the change in y this time is 0, right? The change in y is 0, and over here on the x, we have added 2 each time to get to the next number. So my change in y is 0, my change in x is 2, and when I divide 0 by 2, I get a 0 slope. And 0 slopes are horizontal lines this way, right? And horizontal lines that have 0 slopes always have the same y values. If you notice, all of these y values are the same. So that's one easy way to kind of recognize, hey, that's a horizontal line, slope is 0, if all the y values are the same. Vertical lines, let me go back to my vertical line again. I didn't draw one. This is the vertical line, right? So vertical lines have the same x values, and then horizontal lines have the same y values. All right, so remember that the slope of a line is the measure of the steepness and the direction of the line. Remember that the slope is the ratio of the vertical change or the rise over the horizontal change or the run, rise over run. Remember that you can count the rise distance and the run distance on a coordinate plane graph to find the slope of the line between 2 points without using the slope formula. Don't forget to check your sign, whether it's positive or negative. If it's negative, make sure you add that little negative symbol to it. Remember that you can find the difference between the y values and the x values on a table to find the slope of a line without using the slope formula. Remember that when all of the x values are the same, the line is vertical, and that means the slope is undefined. And when all the y values are the same, the line is horizontal, which means the slope is 0. So that concludes how to find slope with graphs and tables. And now it's time for me to say, it was lovely teaching you math today. See you guys next time. The next video you should watch, by the way, is the one on ordered pairs and equations.